Hello and welcome to this video on linear transformations of roots, and we will be focusing on cubics. So what do we mean by linear transformations of roots? Well, here's an example question. We've been told that the roots of the cubic equation x cubed minus 7x squared minus 14x plus 48 equals 0 are given by alpha, beta and gamma, and we've been asked to generate a new cubic equation which has roots of 2 alpha minus 1, 2 beta minus 1 and 2 gamma minus 1. I am going to show you two methods to solve this question. For method one, the first step, as per usual, is to write down the values of sigma alpha beta, and alpha beta gamma. As we know, sigma alpha is given by negative b over a, which in this case is negative 7 over 1, which is 7. The pair sum is given by c over a, which in this case is negative 14. And the product is given by negative d over a, which in this case is negative 48. For step 2, we are going to evaluate the sum of the roots, given that the roots are given by 2 alpha minus 1, 2 beta minus 1, 2 gamma minus 1, the pair sum of these new roots, and the product of these new roots. So starting with the first one, sigma 2 alpha minus 1, that is the same as 2 alpha minus 1 plus 2 beta minus 1 plus 2 gamma minus 1, which in turn is the same as 2 lots of alpha plus beta plus gamma minus 3. We know that alpha plus beta plus gamma, the sigma alpha is 7, so that gives us an answer of 11. And notice I've put a minus sign on the right hand side, which I'll explain later. For the pair sum, we have 2 alpha minus 1 times 2 beta minus 1, and so on. When we expand the brackets and simplify it, we get 4 sigma alpha beta minus 4 sigma alpha plus 3. Again, we know sigma alpha beta is negative 14 and sigma alpha is 7. So the value of the pair sum for the new roots is negative 81. And again, I've put a plus symbol on the right hand side this time, which I'll explain quite soon. And then finally, the product of our new roots simplifies to 8 alpha beta gamma minus 4 sigma alpha beta plus 2 sigma alpha minus 1, which, substituting the numbers in, gives us a value of negative 315. And for the final time, I've also put a minus sign on the right hand side. And then for step 3, our final step, we're going to write down the actual answer, the cubic equation, but remembering to alternate signs, because as we know, sigma alpha is given by minus b over a, the pair sum is given by c over a, the product is given by minus d over a, and that's why I wrote minus plus minus when we were looking at these sums, to remind us that we're going to have to alternate the signs. So the first term is w cubed, the second term has minus 11w squared because we need a minus b over a, the next term is negative 81w because we need that positive c over a, and the final term is positive 315 because we got negative 315. Again, we're making it negative because it's negative d over a. And now for method 2, which is probably more popular. It requires us to do the following. We write the roots as w in terms of x, and then rearrange to get x in terms of w. Then we substitute these expressions for x in the original cubic equation. So our linear transformation is multiplying the x roots by 2, taking away 1. So we can say in general that w equals 2x minus 1, from which x equals w plus 1, all divided by 2. And then we take this expression for x, w plus 1 over 2, and we substitute it into the original cubic equation. So we get w plus 1 over 2 all cubed, minus 7 lots of w plus 1 over 2 squared, minus 14 lots of w plus 1 over 2 plus 48 equals 0. And because the denominator of the first term is 8, I'm going to multiply everything by 8. So here I've multiplied everything by 8, and then I've expanded the brackets, and our final answer, as it was for method 1, is w cubed minus 11w squared minus 81w plus 315 is equal to 0. So we've got the same answer in two different ways, but let's just have a look at how we might check our answers. So, given the original cubic, we could use the factor theorem to factorize it. F of 2 equals 0, and the factors are x minus 2, x plus 3, x minus 8, which means that the roots themselves are 2, negative 3, and 8. If we take the roots of 2, -3 and 8 and apply our linear transformation to alpha minus 1, the new roots are 3, -7 and 15. If we then multiply together w minus 3, w plus 7 and w minus 15, we do indeed get the same cubic expression in w. And then finally, looking at the sums of the roots, sigma alpha would be 3 minus 7 plus 15 for our new roots, which does indeed equal 11, but we would need to make it negative for the cubic equation. The pair sum is given by -81, which would stay the same sign for our cubic equation. And alpha, beta, gamma, the product is -315, and again we would have to make that into a positive to work out the final term. So here's one for you to try. We have 2x cubed plus 6x squared equals x plus 2, and using the linear transformation 3 alpha minus 2, you've been asked to use each of the two methods to determine the new cubic equation. And here is your answer. Thank you for listening.